Let's explore the fundamental concepts of network security zoning and access management. At its core, network security involves navigating through various access control lists to manage system entry points effectively. When examining network security zoning, consider a basic firewall configuration with 3 distinct interfaces. The architecture consists of carefully separated zones, each serving specific security purposes. The first interface connects to the untrusted public internet zone, representing the external access point. Additionally, there's a dedicated interface for the DMZ, demilitarized zone, which hosts internet-facing services such as web servers and email relays. Moving to the third interface, we find the inside trusted private area. This zone implements significantly enhanced protection measures compared to the other zones. The separation between these zones creates distinct security boundaries, each with its own access controls and security policies. Speaking of access controls, Identity and Access Management, IAM, serves as a critical framework for controlling system access. The IAM framework operates through 4 primary components. First, authentication verifies the claimed identity of users. Furthermore, authorization determines what authenticated users can access within the system. Along with these, user management handles ongoing user account maintenance. Finally, a central repository, such as Active Directory, maintains and manages user information systematically. To illustrate the concept of identification, consider a security badge system. While a badge provides initial identification, it's important to note that possession of identification credentials alone doesn't constitute proof of identity. This distinction highlights the need for multiple security layers in access management systems. Let's explore the critical distinction between identification and authentication in security systems, particularly focusing on their practical implementations. In practice, identification serves as the initial step of claiming an identity. Consider various forms of identification credentials: employee badges with photos, usernames, ID numbers, employee numbers, social security numbers, and badge numbers. While these identifiers provide a baseline recognition, they operate on a declarative level rather than a verification level. Notably, identification extends beyond human users. In technical environments, devices, applications, and services also require identification through specific attributes. These non-human entities typically use identifiers such as unique names, IP addresses, or system descriptions. Moving to authentication, this process involves validating the claimed identity. The authentication process operates through various mechanisms to verify that users are genuinely who they claim to be. For instance, a common authentication method combines username and password verification. Additionally, modern security practices often implement multi-factor authentication, MFA, where users receive verification prompts on their mobile devices. Furthermore, authentication can utilize biometric validation methods, which verify identity through unique physical characteristics. Another robust authentication approach involves smart card systems, where users must both possess the physical card and know the associated PIN, creating a two-factor authentication process. The key distinction lies in the verification aspect. While identification states who someone or something claims to be, authentication provides proof of that claim through various validation methods. This layered approach helps ensure system security by requiring both declaration and verification of identity. Consider a practical example. When a user enters their username, identification, into a system, they must then validate this claimed identity by entering their password and potentially responding to an MFA prompt, authentication, creating a more secure access control process.